everybody. Good morning, Monday, 7th of June. Now is the 9 a.m. Well, first of all, let's take a look at the schedule. The summer sessions actually start from today, the 7th. And the first semester going to start on the 2nd of August. That's about 2 months. That's very quick. Okay, today is going to be short because I have to do something else. But when something pop up in my mind, I just want to explain to our students. Since now our students are not allowed on the campus, and most of them are stay at home, and then I don't know what they are doing, but I just something came up to my mind that I pick up the laboratories manual. This is for junior lab, supposed to be for the first semester. And I think what I'm going to do is I will explain. There are actually 12 labs here, and but actually I cannot do all of them, the labs, because I'm going to use the PSpace, the software for circuit simulation, and student can learn from that. Actually, for the basic PSpace tutorial, I already put on my YouTube channel. You can search from YouTuber CookRT. Many students probably know about it already. COOKR like a rat, IT like a Thailand, and you search for PSpace, and you can study from that. But actually, I will take you along, again with the lab. I will do the circuit. Draw the circuits, and also write down some necessary equations and some theories behind the circuit for you to understand more. And after that, you can go to buy some hardware in the term of electronics devices. For example, transistor of amps, RC. So you have plenty of time during the summer, better than doing nothing. And well, the lab that we will go through, we have a sawtooth generator, we have transistor amplifier, BJT characteristic negative feedback, voltage regulator, phase lock loop, FPGA oscillator, impedance measurements, and oscilloscope probe, power amplifier, Monte Carlo and worst case analysis, differential amplifiers, and constant current source. Okay, so this is all the topic that you have to go through. Sooner or later it will come. So it's better for you to start now, and you can play around with your circuits as the electronics engineer to fulfill your background and be ready to take more courses. It's going to be more difficult for you, deeper and deeper. And sooner or later, you're going to be your senior. Be prepared. So you are the halfway of your study program in electronics engineering. And I also will compare to the lab. That's also for junior. When I study for a PhD program in electrical engineering at State University of New York at Binghamton, New York. Also was the TA, teaching assistant, so I got scholarship over there. And my responsibility is to take care of all the labs in the junior lab, not just like this one. I take care of only one lab. So let's see what the difference you will compare, but I will go through this one later on. Okay, the lab manual in Binghamton University. There are frequency components of periodic wave, transformer equivalent circuit, pulse spectrum, and impulse response. Pulse in a transmission line, velocity servo control system, infrared LED and phototransistor, position servo control system, semiconductor p-n junction capacitance and resistance, power spectral density and power transfer function, ACR and tri-p-n junction characteristics. You also have something about split load amplifier with clamp diode, simple difference amplifier, quasi-ideal differential amplifier, characteristic of real operational amplifier of op-amp. Real operational amplifier, comparator, waveform generator, LM555 timer integrated circuit, frequency selective amplifier, precision rectifier, voltage regulator, digital analog and analog digital converter. So that's all topics that you have to go through. Okay. Again, I don't have hardware. I don't have complete hardware, so I'm going to apply piecewise to do the simulation. So you will see what the voltage, what is the current flowing through the circuit. And sorry, and we explained in my piece of paper. Of course, I have to write out for you. I do the scanning, and then I post on the computer, so I'll be able to explain to you directly. So this is my plan, and if you have something to add up, I will do it for you. So stay input, because this is the one of the good opportunities, and you have the plenty of times that I mentioned earlier, because you don't have to go for co-op or internship, because you are a sophomore or second year students. You're going to be a junior soon, in 2 months, and next year you go for internship and co-op, so you can apply your background. So it's a good time for you to go through all materials that you need to use in the future for either courses or to go to work, and sometimes it can be just like hobbies for you. So that's pretty much I would like to talk today. I have to back to my work, and I will start doing this one for the lab. I will explain to you. Actually, we start from sawtooth generator. So I will draw some circuit. You can generate your sawtooth signal by applying input signal to your circuit, and your circuit is very simple, and it's not just you draw the circuit, you connect circuits, but you should be able to explain what is the voltage at each nodes, what is the current flowing through each electronic components. That's the main point. And later on it's going to get more complicated in the term of you put more and more circuits. You have block diagram, and also we will go through some digital. So we're talking about both analog and digital. This one, the circuit. Okay? So I will talk to you tomorrow again. Today's Monday. Well, have a good Monday. That's very quick. Okay, bye. I could not stop.